Hello, hello. Okay, mic works. He said quietly. We have black. We have camera. There we go. Ladies, gentlemen, children of all ages, and the favorite line I like to use, and adults pretending to be children for tax purposes. Welcome to Workbench Live, Benchtime Live, I think is what I decided to call this. Anyway, this is just kind of a test video. We're playing around with some video streaming stuff. We have a little Blackmagic mixer here that will do YouTube live streaming, and I said, well, that seems like kind of a neat idea. It wasn't initially, I guess, what I thought I was going to use it for, but it is here, so why not? The stream is up, it says. There's supposed to be like a chat deal, so you can kind of talk to me. Normally we would be doing stuff on Discord, but I don't have Discord on this machine because it's too old and it's given me some other weird issues. So anyway, that's kind of the story there. I guess I'll just kind of hang out and see if anybody shows up, because otherwise there's not really a whole lot of point in yantering if nobody's going to see any of this. Although allegedly it will save a copy of the archive for later, so we can see maybe if that generates any traction. So yeah. So what I've got here is just kind of an assemblage of some stuff. So what I would kind of want this kind of channel to be about is, there's a lot of, well, there's several YouTube channels dedicated to the listening end of the hobby, and there's not really anybody out there that's talking much about the operational end of the hobby. So if I'm a guy, I want to go out and do a shortwave pirate show for whatever reason. Maybe you just want to stick it to the man. Maybe you want to use this as sort of an extension of amateur radio because frankly you're bored and there's nobody out there you want to talk to. We won't talk about that, but anyway, you know, various things. There's various reasons you might want to venture into this field. Excuse me. Sorry about that. Nose is a little under the weather. But anyway, when I first started in pirate radio, for me it was always kind of a sort of a springboard into the technology. It was a practical use of the technology, and so that was kind of the reason I got into it, just for something to do, something different. So anyway, that's kind of what I hope the channel will be about. You know, more on the technology end of it. You know, different modes of operation, power amplifier designs, pros and cons, maybe some debate about what all that stuff is or what it does. I think that would be good and probably useful, because I don't know that there's anybody out there that's doing anything like that right now, at least not that I've been able to find. So that's kind of the scoop there. I'll hang around here for a handful of minutes, so if I don't see anybody show up, we'll just kind of bail. But in the meantime, we can kind of do a show and tell. So I built this little transmitter a couple months ago to test an amplifier. I needed just a drive source, and so been kind of kicking around some various designs, and the idea was, hey, I should try and, you know, build something that's kind of on the same platform that I've got now, but incorporating maybe a few little differences and trying some things. And this is a current mode Class D transmitter, as is this. This one's obviously, because of the size of the heatsink, is a little bit bigger. I think on a good day this could probably get you 500 watts or so of carrier power. We've got a little homebrew dead bug style pulse width modulator that I built as well to drive this thing. And it's not great, but it gets the job done most of the time. This one, however, because it's smaller and was designed for, you know, maybe 10 or 20 or 30 watts carrier, the nice thing about that is at that power level you can use one of these little Class D audio amplifier boards that you get off of Amazon for like 10 or 15 bucks, and it becomes your modulator. So that's an easy way to get on the air with a little bit of AM power and do some fooling around. Obviously this is quite a bit bigger, and we'll take a look at this one, I guess, because it's larger and slightly more interesting. So this is kind of the newer, well, it's the circuit board that the PA is based on is an older design than what's currently in use. This just has a crude drive splitter. It doesn't have any of the delay or anti-overlap circuitry in it. It just consists of two MOSFETs, which are buried on the bottom side of the circuit board, and then the FET drivers to make them do what they need to do. Other than that, it's pretty much just a textbook push-pull Class D device. And then this is the card that is the modulator. So raw DC goes in one side through this lead, and we've got some reservoir caps up here to stiffen the power supply rail a bit, and this just basically chops up the DC into little itty bitty pieces, and the duty cycle or the pulse width of the pulse train coming out of this corresponds linearly to the average, or to the instantaneous peak voltage required by the PA. So when you go to 100% modulation, the pulse width gets wider, and when you go to cutoff, which is like 100% negative modulation, it goes almost to zero. And then this filter turns that back into a smooth, clean DC that we can feed into the PA. And it's set up in such a way that it will not truncate the audio portion of the DC, but it will get rid of the switching component. So it acts like a passive integrator. So that's kind of how that works. Yeah, we have a human out there, apparently. That's interesting. So anyway, this is just kind of, I call it a junk box transmitter because it was basically made out of parts and circuit boards that I had built for other things, and it was just kind of parts I had laying around. So, but it's a fairly large chunk of a heatsink. This was actually a piece that's commercially available from some vendors. The extrusions are all kind of the same, but I called them up and I said, hey, can you just send me a piece of extrusion to, you know, evaluate? And they sent me two of these little pieces, which are quite heavy. And like I said, this particular transmitter, if you want to call it that, is around the, probably capable of the 500 to 600 watt level. Not nearly as clean or good sounding as the main transmitter, but nonetheless can be used for that sort of thing. And again, this is the small one. For the record, I will leave the archive of the stream up on the channel, so if you want to look at this at a later date and we can kind of explore other things or talk about stuff or whatever. So anyway, this is just kind of a test. I just wanted to make sure that this works and that, you know, the video and audio quality are sort of okay. I'm using a crappy gaming headset, and it does kind of make some rumbles and some booms and some unpleasant noises from time to time, but that's just kind of the way it's going to be for now. But yeah, so whoever's out there watching, I guess, can drop something in the chat box if they would like to, or you can just kind of sit there and see what's going on. But anyway, yeah, that's kind of some things that I've worked on over the years. And like I said, for small transmitters under the 20 watt level, these little Class D amplifiers, this one's missing its heatsink, seem to do the job just fine. This is another sort of variant of the same thing. I think it's a TP3116, which is a TI Class D audio amplifier IC. And most of the amplifiers based around this chipset seem to work pretty well, because that's what these two are, and I know that these work. I haven't been able to get this one to work for some reason, because usually you're supposed to get like a floating DC on the output, and I, for whatever reason, don't have that on this one. So it could be that it just has a problem. That's entirely possible, because, you know, it is Chinesium, so you never quite know what you're going to get. Let's see, do I have anything else that's kind of neat? Dig around in the junk bin here. So this is something else that I was kind of working on recently, and in pursuit of higher power with relatively few components, the notion crossed my mind that some of these switch mode regulator ICs have most of the circuitry that you need to basically build a modulator. And so this was one such prototype. I think this uses a what is it, a 33167, an MC 33167 from ON. And the neat thing about these regulator ICs is they're externally compensated, and so you can sort of just ram a DC voltage with audio riding on top of it into that compensation pin, and the error amplifier basically at that point is taken out of the equation, and it behaves pretty much just like any other pulse width modulator. This one will work up to 50 watts. The only thing that I don't like about it is the transistors that are in the pass regulator, or in the switch in the device, are bipolar, and so because of that they don't switch as efficiently as a MOSFET would, so they do get kind of warm. But even so, running this at the 50 watt level, even with this tiny little heatsink stuck to it, you couldn't hang on to it and it wouldn't burn you. We've got just a material 3 inductor here that I wound, and then a material 26, so this is like a 2-pole low pass filter for the reconstruction. And I've got a little BNC port on here so I could hook it up to the scope and look at it. There's a RCA connector, what the Dutch call a tulip connector, on the input. And that's really about all there is to say about that particularly. Like I said, this will do pretty much most of the same thing that this does, just without the power stage. I needed something to drive this modulator card to get pulse width modulation, and so this is just a scrap board I built sort of dead bug style, using parts that are common and cheap. So I think there's like a TLO72 front end with a balanced to unbalanced converter, so it does have balanced inputs. And I think I'm using a switch mode power supply controller IC as the ramp generator. It's like a UC38. Is it a 38? 3843. Yeah, as the oscillator and triangle wave generator. And that goes into an LM311, which basically compares the floating DC with the audio riding on it against the triangle wave, and then what comes out the back through this push-pull driver state, or this totem pole driver, is basically 15-volt TTL that you use to drive the modulator. So yeah, that's just kind of some stuff that's kicking around my workbench. Again, didn't really intend to go into a whole lot of detail or anything. It's just kind of a show and tell sort of thing. But yeah, maybe we'll start doing some of this on a quasi-regular basis, and as I mentioned, try and kind of cover some of the important points of what makes pirate radio neat, some of the technical challenges, some of the things that you can use to make your station better, or sound better, or be more reliable. These are all good things, and as they say, Rome wasn't built in a day, so it's always kind of a constant struggle, and it's a constant process. So whatever we can do to kind of make that a little easier, I think is worth exploring. So I think that'll do it for now. I am Red Hat, of course. I am a broadcast engineer. I have worked on commercial stations for the last 20 years. I've been involved in electronics design, construction, commissioning, that kind of thing. So I've been around the block a time or two, and you know, it's fun for me as a hobby to kind of explore building some of these things myself. You know, it's one thing to work on commercial transmitters all day. It's quite another to actually build them and put them through their paces and see if they work, see if they blow up. It's an interesting learning exercise. So anyway, from my bench to yours, I guess we'll call this a wrap. So until next time, have fun, and we'll see you then.